Algebra 2, Lesson 113. You guys, we are entering into what I consider to be the last major subject, last major content area that we're going to explore in Algebra 2. The topic is logarithms. That is a complicated and difficult sounding word, but here's the good news. You already know. You already understand what logarithms are, because logarithms are exactly the same as exponents, okay? And you understand exponents. So understanding logarithms is not that different. It's kind of like saying you already know how to speak Spanish. Now we're going to learn how to do Pig Latin in Spanish. It's just a twist on what you've already learned. So don't let that scary word freak you out, and let me show you what I mean. This, I guess I'll put it over here. I'm trying to put it underneath the exponents part. If I tell you to take 10 and raise it to the third power, you know how to do that. You put a 1 with 3 zeros after it, right? This number is called the base. This number is called the exponent. And then this number, which is a combination of those two, right? You have to know the trick for how to take this number and that number and create the new number. And for lack of a better term, we're going to call this the number. It's the result. It's the end of the calculation, right? This is simple. You know how to do this. With your calculator, you can do bases that are different than 10. 10 is the easiest one to do in our heads, right? But you know things like 2 to the third power and 4 to the second power. You've got a lot of them memorized, and you know how to use your calculator to do even more, okay? So this is what we know. With a logarithm, we're going to take this same information and write it differently. This is the way it's going to look when we write it in Pig Latin Spanish. I don't know if that's helpful or not. Okay. I'm just going to draw a line to separate these two so you can see where one ends and the other begins. In this sentence, which we say the log of 10 with 3 is 1,000. This is our base. This is our exponent. And we can call it the exponent, but we can also now call it the logarithm, or sometimes we just call it the log. So we'd say the log 10 of 3 is 1,000. This is what we inglamorously called the number. It's the result. Now here comes the part that's just going to make you feel weak in the knees. The special thing we call this in logarithm language is the anti-logarithm, or the anti-log. Oh, I don't like that. Against something, to go against something, I don't like that feeling at all of something being anti. So anti-log just means the number, okay? It's not scary, it's not hard. We've got all the same players and the same kind of calculation, we're just presenting it differently, okay? Now, the rules of exponents, which you know because I've beaten them into your head. There's the product rule, and we're going to review them in more detail later. The product rule, the quotient rule, and the power rule. I'm not multiplying those, I'm just putting the little dots to separate them. These all apply to logarithms. There. A lot of consonants in a row. So we're in a future lesson, we're going to specifically look at each one of the rules of exponents and talk about how they look in logarithms. So this is just a little preview of what's to come. But that's just a reminder that you really already do understand this language. We're just putting this slightly new spin on it and looking at it from a different angle. It's the big Latin of Spanish. I'm not joking when I say that. Okay, we are going to use our calculators to do this, and that's tricky for me because my calculator is up there recording this. So what we're going to have to do is I'm going to talk you through it and tell you what the buttons look like, and then you'll have to try it as you listen to this. But I want to show you what the buttons are. There are 4 buttons on your calculator. These are the buttons. Hi, Luna. I had a dream that I took my cat Luna to a lake and discovered that Luna loved to swim. And he spent, oh, it's not Luna, it's Sirius, it's the other cat. But anyway, my little black cat was a crazy swimmer. And he was like swimming all over the place and soaking wet. And then he'd get out and shake like a dog. It was really a funny dream. Do you want to go out? Here, let my cat out. Thankfully, I'm right by the door. Come here, kitten. There you go. Have fun. Be safe. Good kitten. Such a nice day. Okay. 4 buttons that you need to know how to use. I'm going to start with this one first. It looks like this. This button is useful when you know the base and the exponent, and you want the number. Okay, that's like our example up here, right? We had 10 to the third. If you couldn't figure out that that was 10,000, let's say you don't speak Spanish yet, then you could enter 3 into your calculator, hit that button, and the answer would come out 1,000. All right? This is much more useful when we have something like 2.87 and you don't know what that would be. The whole numbers are pretty easy to calculate. Okay, so this is when you know the base and the exponent, because there's the base and you're going to put in the exponent, but you want the number. So that's useful. This button, which is usually located directly below it, is when you know the base and the number, and you want the exponent. So what I'm telling you, 3 variables, whichever way you look at this, there are 3 variables. You have to know your base in all of them, but this is when you know the exponent and you want the number. This is when you know the number and you want the exponent, okay? So this you for sure want to copy down. We're a little late in the game to be talking about this, but I really think that it would be most helpful for you guys, Jayla and Lydia, to practice taking notes from these recordings, these videos. It's super easy because you can just pause me if you need a little more time to write down. So I do recommend in these last few lessons we're going to digest, practice taking notes. And in fact, I'll wait right now. Pause me and run those, and you can practice now. Well, I'm back. My neighbors are having a fight, it appears, in Chinese, which always makes it interesting. I'm going to shut the door just a little bit. Side note, this family moved into the house directly behind ours not quite a year ago. We know that they're Chinese. We hear them speak it. We know that they seem to go back to China quite often. Whenever there are school breaks. They have 2 kids that are school age, kind of like middle school, maybe early high school. And there's a woman that's clearly their mother, and then there's a man that's either their father or their grandfather. We can't tell. But they're having quite a row right now, which is a little unusual. But, you know, coronavirus does crazy things to us all. Okay, back to logarithms. This set of buttons is for base 10. Now, we can use logarithms with any base we want, and I talked briefly about that, how you guys have already got memorized 2 to the third, for example, 3 to the second. There are different bases. We can use any number as a base. It's just that 10 is super common because our counting system is called a base 10 system. Now, there's another base, and I use base 10 over here too, because again, that's what we're familiar with. There's another base that is super popular and common, used in the sciences, physics and engineering being two really strong examples. It's called the natural log, because it appears in nature quite often, and it's abbreviated as e, a lowercase e, and numerically it's about equal to 2.71. It's an irrational number. It's got a bunch of decimals. What is important for you to know right now is that we can do calculations using a base of e just as easily as we can a base of 10. We just push this other set of buttons. So the way the buttons look, it'll be e to the x. See, it looks just the same, right? This is when we know the base and the exponent and we want the number, right? So if you wanted to have e to the second power, you would put 2, hit that button, and it would tell you. Now, this one isn't any harder, but it just looks weirder because it's a lowercase l and an n. I make mine cursive. The calculator has just a button like that, so it looks like it says 1n. It's confusing. This stands for natural log, and it works the same way as this button, just on a different base. It's when we know the base, yes, e, and the number, and we want the exponent, okay? So these buttons work the same way, these buttons work the same way. This is for base 10, which is familiar. This is for the natural log, which right now feels really weird, okay? So don't worry about this. We're going to do some problems with it. This will probably feel more comfortable. All right, we're almost ready to start calculating. And what I want to give you one more piece of information. Sounds like World War III has come to at least a temporary truce. Okay, the base of a logarithm can be any positive number, okay, so it can't be negative, except 1. We can't use 1 as a base. And if you think about how 1 behaves with exponents, that will make sense, because 1 to the first power is 1, but 1 to the 100th power is also 1. So 1 doesn't behave in a very useful way when we raise it to different powers, so that's why we don't use it as the base of a log. So any positive number except 1 is in our puffy cloud of knowledge. Okay, so now let's do a couple problems. I worked them out before I started this lesson so that I could just make sure that they worked, but because I'm not going to be able to show you on my calculator right now, you'll have to figure them out your own little self. Go grab your calculator right now if you don't already have it. Pause me. The first example says, use your calculator to get a value for e. Okay, this is a good question because everybody forgets the value of e. I told you it was approximately 2.71, and that's true, but you aren't always going to have me sitting there. So all we have to do is remind ourselves that if we calculate e to the 1, that will give us the value for e. So we go to, look, here's my handmade calculator. So we want to use this button because we have the exponent and we want the number, right? So we're going to hit, first we'll hit 1, and then we'll hit e to the x, and the answer will come up 2.718281828, blah, 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 okay? So you'll get some form of this in your answer, and that is the correct answer. So I should say that if we're going to round the value, it should be 2.72. I said 2.71, sorry. But there's the answer, okay? And that just shows us that using the E buttons is exactly the same as using the base of 10 buttons. Okay, so this is our answer. Let's round it to 3. All right, example. So the first one didn't hurt, right? It didn't bite much. Okay, and just getting my little calculator page ready. Okay, this one is more like what we're going to see. It says use base 10 logarithms to simplify. And then there are 3 numbers that are kind of big and kind of ugly. Now, in our day, we would look at this and go, why do we need to use logarithms? Why don't we just plug it into a calculator? It's not that big of a deal, right? That's 100% true. Logarithms were developed before there were calculators so that mathematicians like you and I could handle calculations like this fairly efficiently without having calculators at our fingertips. Handheld calculators came out when I was in either late middle school or probably late middle school. It was the very early 70s. Before that, people just had to do these by hand, and there were tables in books that helped you change numbers into logarithms, and there were slide rules that did much the same thing. Calculators came out and turned all that upside down. We don't have to deal with those anymore, and honestly, we don't really need logarithms in order to make calculations. We study logarithms because they help us understand how numbers behave, and it's kind of like studying Latin, where it's just a very formative, foundational piece of education that we all respect. Okay, so we have to turn each of these numbers into logs. What we want to create is we want to create a new version of this fraction, because that's what it is, right? It's a fraction with 3 parts. And instead of having these big wonky numbers, we want it all to be powers of 10, okay? So what we want to use in this case is we want to use this button. We have the numbers, right? These are the numbers that we want to represent. And we know the base, it's 10. We want the exponent that goes on top of that 10, that base of 10. So this is the button we will use. And the way we do it is we type in this number, try it now, make sure it works. Type in 47,832, then hit log 10. And what you should get is, rounded to 2 decimal places, you should get 4.68. Okay? Round them properly. Now we're going to type in, oh, I copied this one. It's 59,463. Okay, now type in 59,463 to your calculator, and again, hit this button. We have the number, we want the exponent. When you do that, John says it's 4.77. When I did it, it rounded to 4.78. So I'm going to use the number my calculator actually told me. As we do these problems, you'll run into this. Sometimes John rounds at a different place than we do, and we may be slightly different in our answers than him. That's okay. We'll talk more about what's acceptable and not acceptable as we go. Now we do this number, 0.000817. As we type it in, we go, dude, that's a weird looking number. It's way smaller than 1. How are we going to get the exponent on this? And then we see the answer, and it is minus 3.09. We go, oh, right, that's how we do exponents for numbers less than 1. We give them a negative sign, and that flips them down into the bottom, and that makes them a fraction, bingo, that will work, right? Now, I told you up here that the base of a log can be any positive number. And here we have a negative number, and your sirens may be going off saying, wait, I thought we didn't do negative numbers. We're both right. The base of a log has to be a positive number, but the exponent can be negative. That's fine. So we're okay. All right, so now we have rewritten our fraction using logarithms so that it's a power of 10. Now we have matching bases. Now we can use our rules for exponents. And you remember that when we're multiplying matching bases, we add the exponent. And when we're dividing by a matching base, we subtract. So what this is going to be, I'm going to write it over here, it's going to be 4.68 plus 4.78. Okay, so that much is 9.946. Then we're going to subtract the minus 3.09. So this is actually going to turn into a plus, isn't it? And so our final answer, I added them together, I got 12.55. So our final answer equals 10, oh my gosh, that's squishy, 10 to the 12.55. And if we wanted to, we could calculate this number using this button, because we have the exponent and we want the number, and we could run that through. I don't think John requires us to do that. No, he doesn't. Sometimes the solutions manual want this stated as an actual number, and so that's where we would use this button. We'd push in 12.55 and then hit 10, and that would give us the actual number. Okay, so we're doing it. We're using logarithms, you guys. We have 3 more problems, all of which involve our calculator, so keep it handy. This time, we have a similar problem. It's the exact same problem, 47,832. It's these very same 3 numbers again. Three zeros, 817. Okay. This time we're going to simplify this expression, but this time we're going to use the base of e instead of the base of 10. Okay, so here's how we set it up. Don't be scared. I'll help. Okay, it's going to look exactly the same, right? I'm making mine super big, so we'll have room to write the exponents. The base is not going to be 10, the base is going to be e, which simply means we're going to use this natural log button instead of this one. So we'll work it the very same way. Enter 47,832, and then tap natural log. And you'll get the exponent that belongs here, 10.78. This number is the same as this number. Crazy, right? And then we do the same for the other 3. 59,463, we enter, and then hit this button again, natural log, and that will give us the exponent of 10.99. Okay, and then this one, enter this number on my paper calculator, tap that button, and we'll get minus 7.11. Now I just want to remind you again, this looks weird because we're using a letter. This letter actually stands for 2.72 blah 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 blah, right? So this is a number that we know, we just abbreviate it with that E, that's the custom. Okay, so now we have rewritten this original expression as exponents based on the base of E, and so now we can use our product and quotient rules again to simplify. So it's going to be 10.78 plus 10.99. Let's do that much. 21.77. And then we subtract the bottom number, which is minus 7.11. It's minus a minus, so we're actually adding it, aren't we? So that will be 28.88. So that's our final answer. E equals 28.88. And we go, wait a minute. Is that the same as this number? Because it's the same problem, it should be. If you take this number, 28.88, and you enter it using this one, we have the exponent, we want the number, you can calculate the exact value of that. I'm just looking to see. Out to the very same number as example 113.2 if you calculate both of them and find the number. You'll just have to trust me that it's right now, unless you want to do that. I can't do it to prove it to you because my phone is my calculator. 113.4, if that number okay, this looks confusing and hard. If that number equals the log of e to the y, find y. Okay, what are they saying? They're saying that, I'm looking just at this expression, and I'm saying, okay, this is the number, this is the base, and this missing piece is the exponent, and we're supposed to find that. Okay, this is going back to the original diagram that I wrote back here, right? Base, logarithm, number. These are on opposite sides of the equal sign, but it's the same difference, right? Base, exponent, number. So we've got all the pieces that we need. This is the number. We have the number and we want the exponent. So have number, want exponent. That means we're using one of the bottom buttons. Are we using a log of 10 or a log of... Oh, it's a log of e, so we just use this button. So we enter 0.0325, make it minus, and then tap natural log, and we should get equals, this is the number that will show up in the calculator, 0.968. So that means that this number is equal to e to the 0.968. Okay, so this is our answer. This is just what it means. All right, I hope your brains are not exploding at this point. I really wish I could see your faces to see if you were like, yeah, okay, kind of, yes, I think this will make sense, or if you're just like, I got nothing. I've got nothing. I'm assuming that you're kind of in the yeah zone, because you guys usually are. Incidentally, I'll just tell you that you guys both got the exact same score on the midterm, which I thought was really cute. 4302. Okay. All right, if y equals that number, find the log of y and the inverse of y. Now, something interesting has happened here. We haven't written the little 10 down here, have we? That's a shortcut. Because this, we work so, when we use the word log, it's almost always log 10, although it could be but because we so often use 10, the 10 there, if we just write the log of y, that's the same as writing the log 2 of y. This is a puffy cloud of knowledge. This is, oh, I'm sorry, 10, not 2. All right, it's kind of like, this is why I was if we just do a square root thing, that's the same as if the little 2 is there. Because it's the most common, we don't bother to write it in all the time, right? And the same thing is true of the 10. If there's no number there by the log, then you know it's base 10. Okay, so that means we're supposed to be finding, now I've used up all my room, the log 10 of 4302. Okay, what does that mean? That means the number. I haven't written this properly, but I think the way that the problem is written, I think it's confusing. Is this the number or is this the exponent? It's hard to tell. It's supposed to be the number. So we're supposed to be saying log 10 of what equals 4302. That's not the way the problem looks to me. I think this is a confusing problem. But that's what we're supposed to be doing is this is the number, this is the base, so this is the button we want to use, right? Because it's when we have the number and want the exponent. And so we enter this 4,302, we tap this button, and we get as an answer 363, so the answer is 10 to the 3.63. If you're confused about how that was set up, don't worry, you're right on the money. If you get a problem like this in the homework, let me just glance quickly. No, the ones in the homework are more straightforward. And then the same for this one. What's the natural log of e? Okay, we're going to use equals 4302. We've got the number. We want the exponent. That's this row of buttons. We want the natural log button because that's just what we're using. And so we find out that this equals, that's an e. That's confusing too. There, that looks more like an e. E to the 8.37. Try that and make sure it works. So, these are the final answers on that one. Okay, that was 113.5. Like I said, the way this is written and set up, I find very confusing. But when you go to look at the practice, you don't have to worry about that. It's clearer. Okay, that is our first lesson in logarithms. If your brain is swimming, I understand. Listen to this another time or two maybe, but trust me, this will become easier as you get the hang of it. It's kind of like trig functions, right? We're using the calculator and all these weird numbers. It's intimidating at first, but you'll get it. Okay, that is the end of lesson 113. I will see you in lesson 114, which goes in a completely different direction. Don't worry, your brain is done for today with the really hard stuff.